Today's lesson is called Laws of Exponents Review. So for the first three questions, we're going to fill in the blanks to complete each sentence. So in number 1, to simplify 7 squared raised to the 4th power, I need to, so we're going to look at that. That looks like power to a power because I have two exponents right next to each other. We're already squaring 7 and then also raising it to the 4th. So this is a power to a power situation where I need to multiply the exponents to get, if we did that, we'd get, keep the base of 7, 2 times 4 is 8, 7 to the 8th. To simplify in number 2, to simplify negative 3 to the 7th times negative 3 to the 8th, I need to, so looking at that, that's a multiplication problem. When we're multiplying, we are supposed to add the exponents and keep that base to get negative 3 to the 7 plus 8 would be 15. Notice when I use this rule, because the base was negative 3, anytime you have a negative or fractional base, you need to make sure that that base stays in parentheses. So in number 3, to simplify 6 to the 10th over 16 to the 10th over 16 to the 4th, I need to. So when we see a fraction like this is division. And if we're multiplying, we add the exponents. It makes sense that when we're dividing, we would subtract the exponents. So again, we keep that base, which is 16. And then 10 take away 4 would be 16 to the 6th. So that's a quick review of each of the 3 rules that we've learned. So what I'd like to do now is go through and complete questions 4 through 12. This should say 12. And use our laws of exponents to simplify each expression. Then we'll evaluate any numerical expressions. So in number 4, 2 to the 3rd times 2 to the 3rd, that's multiplication. So we keep our base and add our exponents. 3 plus 3 makes 6. If I were to type 2 to the 6th in the calculator, I get 64. Make sure to use that button on your calculator that looks like this in order to get the cursor to the exponent spot. In number 5, we are dividing because it's written as a fraction. So when we're dividing, we are supposed to keep our base of 6 and then subtract our exponents. 7 minus 5 would be 6 squared. So if I were to evaluate 6 squared, that's 6 times itself 2 times. 6 times 6 is 36. In number 6, we have 2 little exponents next to each other. So 4 is already raised to the 3rd power and then also raised to the 4th power. So this is power to a power. We want to keep our base and multiply our exponents. 3 times 4 is 12. Now in number 7, we still have a multiplication problem, but this time we have coefficients out in front. And this is going to happen in number 7 and in number 8, also in number 9. We're going to try these 3 with coefficients for each of the 3 rules that we practice. So in number 7, our coefficients are negative 5 and negative 6. So we would multiply them the same way we always multiply numbers, which would be to get 30. Then our bases are P. So we're going to keep our base. And because this is a multiplication problem, we are going to add our exponents. So 8 plus 2 makes 10. In number 8, we still have coefficients. We have a 27 and a 3, but this time we are dividing. So the numbers should be divided the way they always are divided. This should be 27 divided by 3 is 9. Then we are going to keep our base. Our base is y. And because we are dividing, we are going to subtract our exponents. 10 take away 2 would be y to the 8th. Then in number 9, our coefficient is 3. This is power to a power, so it would be very helpful to put that little exponent of 1 on that coefficient of 3 so that you don't forget to include it when you do power to a power. So for power to a power, we're going to take this exponent of 4 and multiply it by all exponents inside the parentheses. So 3 is going to stay 3, but then we're going to do 4 times 1, so it'll have an exponent of 4. That 4 has to go to the coefficient as well. Then we will keep our base of p, and 4 times 7 makes 28. We can evaluate 3 to the 4th by doing 3 times itself 4 times, which would be 81 p to the 28th. Okay, so to look at just some more complicated ones in the last row, 10, we have 2 different bases. So we have to remember here that we're only allowed to use the rule on the bases that are the same. So first, I see m to the 8th n, and n really has an exponent of 1, so write that in. And then we are going to use the rule on the m's, and then we can use the rule on the n's. We cannot use them together. So for the base of m, I will keep the m, and I will be adding, because it's a multiplication problem, the exponent of 8 and 3 to get m to the 11th. And then for the n's, I will keep my base of n, and I will be adding 1 and 5 to get an exponent of 6. So this one should be equal to m to the 11th, n to the 6th. In 11, this is a division problem. Once again, we can only use the rule on bases that are the same. So for the a's, we are dividing, so we're going to subtract our exponent. We keep the base of a, and 15 take away 12 would be 3, so a cubed. And then we get into this special situation here in 11, where b squared and b squared are the same on top and bottom. What happens anytime you take a number and divide it by itself? It always equals 1. So we're able to cancel these right out. And then c to the 18th and c to the 3rd, we're going to keep our base of c. 18 take away 3 should be 15. So our answer is a cubed, c to the 15th. Then in number 12, we've got a coefficient of -9, plus we have 2 different bases. This is a power to a power rule. So keep in mind that this -9 really has an exponent of 1 there. So we have to make sure when we multiply our exponents, 2 gets multiplied by the 1, the 6, and the 4. Now be very careful with this -9. That's a negative number. So it should be written in parentheses to show that it's an actual -9 as a base, and then 2 times 1 would be 2. R, we're going to keep our base, and 2 times 6 would be 12. And then S, we're going to keep our base, 2 times 4 would be 8. We can simplify -9 squared. Be very careful that you type the parentheses into the calculator. Without the parentheses, this is going to look like it equals -81. When with parentheses, we're doing -9 times -9, which is actually 81. So our final answer is 81, r to the 12th, s to the 8th. For our last 2 questions, 13 and 14, we're going to review once more how to use multiple laws of exponents to simplify each expression. And then anything that is numerical, we will evaluate, just so that we're always practicing both. You never know what the question is going to ask you, so we have been practicing both all along so that you're prepared either way. So we'll start by using our laws of exponents and getting an answer in exponential notation. Now, the first thing I see going on in this problem is actually power to a power. And it's very important you do that first, because in order of operations, parentheses comes before everything else. PEMDAS starts with a P, right? So then we have exponents, and that's what we're going to handle here. I know you're looking at a bunch of exponents, but power to a power is having 2 exponents. That should be the priority of what's done first. So we are going to take 6 and 2 and multiply them. So this is 5 to the 3rd. Since they were written right next to each other, this is a multiplication problem. And then using power to a power, 5, we keep the base, and then 2 times 6 would be 12. Now multiplication comes before division in this situation because the fraction is the overall last step. So 5 to the third times 5 to the 12, we're multiplying, so we add our exponents, keep the base of 5, and add 3 and 12 to get 15. And then since this is a division problem now, we are going to keep our base of 5 and subtract our exponents. 15 minus 2 would be 5 to the 13th. And then since this is a numerical base, just so that we're always practicing, you can type that in the calculator using that button, the insert button, to get up to the exponent position, and you would get 1,220,703,125. And then in our last example, number 14, we have multiple rules and we have some coefficients. So don't let it overwhelm you. Thinking of order of operations, parentheses, then exponents. So remember, that means power to a power should be taken care of first. There's really a 1 on this 4. So this power to a power, make sure the 3 gets multiplied by the 1 and by the 6. So this problem is now negative 3k squared multiplied by 4 to the third, and then k to the 6 times 3 would be 18. 4 to the third is really 4 times itself 3 times. So this is really negative 3k squared times 64k to the 18th. So now we can multiply our coefficients. Negative 3 times 64 would be negative 192. They work the way numbers have always worked. And for our multiplication exponent rule, we are going to keep the base of k and add our exponents. 2 and 18 would make 20. So our final answer for 14 is negative 192k to the 20th. And that concludes our lesson on our laws of exponents review.